Hey guys, welcome back to the shop. Today we're going to take this square tool steel rod, cut it up into a bunch of tiny pieces, and make a super cool knife. If you're able to purchase small steel cubes, I'm not aware of where you can do that, and so I have to make my own. The only thing that I found that was remotely close was a bunch of magnets, and while those might forge well together, I decided to go with a carbon steel that I was familiar with. This is W1 tool steel. Pretty decent blade steel. High carbon with a little bit of alloy component to it. These are 3/16 inch square rods. And I started with 36 inch pieces, 10 of them. And now they're down to a length that I think I need to go ahead and clean up all of the surfaces while I can still hold on to them pretty easily. And that is something that has to be done on the belt grinder. This has some mill scale on it, just your typical cold rolled or even hot rolled surface finish on your steel, and I don't want that in there because these pieces are all going to be forge welded together in a canister once we finish processing them. The total prep time on this took me an entire day. While I was working on this, I also cut up some stock for a bunch of other normal pattern welded Damascus billets, so that was good. The saw could run while I did that. And then while I was actually cutting up these little pieces here, I was just kind of hanging around the saw and restarting it every 3/16 of an inch. You can see here in the beginning I was trying to figure out how to contain or retain these little cubes of steel. And I know what you're going to say, why don't you clean out your saw and get all those shavings or saw particles out of there? Well, to quote Barney Fife, if you do everything the easy way, you never learn anything. But the real answer is, even if I did that, all of the saw particles would still be mixed in and I would still have to separate them out. So, yeah, it would not be easy no matter how you did it. Finally settled on some paper and just picked it out. Now I'm trying to clean it all up. This is the next day. I've got some acetone in this container and trying to clean all these up, get all the little particles of saw particles out of there. I'm going to fill the canister that I prepped halfway with these steel cubes, and then put in my nickel content powdered steel, vibrate that down, and then fill it up the rest of the way. I don't want any voids. I want to make sure that that powdered steel is all the way in there, and if it has to travel all the way from the top, then it may not reach all of the voids. So doing it half and half should work better, be more reliable. My canister, of course, is a 2-inch square mild steel tube coated inside with white paint, and the titanium dioxide content in the paint keeps the contents from welding to the can. This is me struggling to get this out of the leg vise. Got it all welded up, minus a little vent hole, a little pinhole, so that it doesn't explode in the forge, and we'll start heating this thing up. I got this billet nice and hot, and there's a range of forge welding temperature you want to have here. It all has to fuse together into a solid piece. Theoretically, all of the contents are protected from oxygen by this canister. The initial forge weld heat is long enough that I can press it several times in the forging press. The second heat here, you'll notice that the billet is sticking in the squaring dies, and the reason for that is because of residual borax flux on the floor of my forge from previous regular pattern welded billets, and it's a pain in the neck. It destroys your forge, sticks to your workpieces that you're not trying to flux, and there you see I'm scraping it out. It's like molten glass. But we got our billet forged up and all solidified into one mass. So it's time to peel this mild steel jacket off of it. If everything goes well, it should just be a matter of cutting it in several spots and then using a punch or chisel to separate it from the contents. I've had really good luck with the white paint. Even at this higher heat here, it still did its job. I have had the stainless steel foil actually forge weld partially that sometimes you can use to create that barrier. So now I just need to forge this out into some stock dimensions that we can then forge a blade from. And as per typical with canister pattern welded, you'll get some surface cracks or inclusions where the billet was being pulled in a lengthwise fashion while also being squished. It's just a physics thing, and that material on the outside didn't have a chance to fully forge weld before it was pulled apart. But that is why I added those pieces in the corners to minimize that, and it did help. Now that we've got the billet drawn out and the surface cracks dealt with, cut this off at an angle and start forging the blade. We have enough steel here for several knives, but I decided to make one large knife out of this billet. I think having sort of a larger canvas to display this pattern should be cool. I hope it turns out that way anyways. At this point, the steel is still about 5/16 inch thick, and I'm going to forge the bevel in a little bit. But first I'm going to establish the tang. And to be honest, I was originally going to do a hidden tang design, but then as I started to forge down the step here, it really just kind of worked itself into a full tang. Just the way it was looking, it was inspiring me to go ahead and do a full tang, and so I did that. And I think it turned out pretty cool with the profile or the design. We'll forge out the stock, taper it out a little bit on the handle. You'll notice that the end of the tang on the handle has got some stuff there that I'm going to cut off. That's just the end of the billet that's not usually the best bit of steel regardless of what material you're working with. And now on to forging the bevel. I'm going to leave it pretty thick, but I do want to forge it in a little bit just to maximize the use of the stock we have here and stretch that out a little bit. Still dealing with that flux pooling at the bottom, in the bottom of my forge there. Brushing that off every time I pull it out, otherwise you leave it on there and you hammer that into your steel, creates a big old divot. Not fun. So straightening the blade out here and finishing up the final forging process. Before we go into normalizing and further heat treating, I cleaned up the profile on the grinder, and I'm really liking how this is looking. Overall, seems to have some good balance to it, although the front end of the blade specifically is going to be quite a bit lighter by the time we're done with it. So we'll normalize this at 1600 degrees, pull it out after a soak time, and we'll let it air cool. And then I'll follow this with a couple of grain refinement cycles at 1450. So this blade is actually a large part 1080 powdered steel, and then that powdered steel has about 4% nickel content in it. And of course the blocks of steel are W1. This is where my camera glitched, but we got it quenched and hardened. And this is right after the quench, just checking for straightening as the blade slowly cools down, and check for hardness. After a pretty decent decarb layer, got down to nice hard steel. After 2 tempering cycles, the next day we'll finish grind this big old chopper. Start by taking the corners off of the bevel with a worn out belt, and then just getting the scale off with the same belt, and switch to a clean belt or a fresh belt, and grind in the bevels. Putting a convex grind on this blade using my slack belt attachment. For a big chopper like this, that'll provide that edge stability and toughness, as well as a edge geometry that'll help pop out the chip of whatever you're chopping, branches, wood, whatever. Got this hand sanded up to 220 grit, and put an edge on with the 220 grit belt, and then buff it out for a razor sharp edge. And we're going to run just a quick test on this, chopping through a 2x4 a couple times. At the start of the test, it did take hair off. I wouldn't say it's the sharpest, but it was shaving. And we'll go through this 2x4 a couple of times. And it still took hair off following that test. Of course, this is a combination between steel selection, heat treatment, and edge geometry. Final test here, just to see if we can do the cardboard tube test, and it was not the best at it, but it would cut through there. Final hand sanding, and then we can etch the blade, revealing the pattern. Alright guys, well, we've run into a serious issue. Been etching this knife, cleaning the oxides off per usual, and it started looking pretty cool. Pretty cool knife all the way around. But as I continued to do the etching process, third or fourth trip into the etch here, starting to see some unsettling things here. And that is specifically, and I'll show you some close-up pictures of it here, but around the perimeter of some of these different pieces of W1 steel, I'm starting to see all throughout the blade, specifically in certain areas, tiny little what appear to be cracks or something to that effect, and they're filled in. There's no voids, but little striations around the perimeter and into the interior of these different pieces of W1. Almost as if it opened up and then was filled with the nickel and steel powder. And from what I know as of right now, that can only mean one thing, that this got overheated to a level that it should not have. And you know, it's one thing to have an issue, it's even worse to not know how it happened. Fortunately, if that's what this is, and I'm 90% sure that's what this is, I do know how it happened. I recently modified my forge, closed off the back end, and put in a new front piece that's a little bit smaller opening, so the forge gets hotter running at the same PSI than it used to. And that could be good, or can be good, but if you are not taking that into account when soaking a canister or billet, that's not good. And so there was a point where looking back, I can say, okay, yeah, I think that that got overheated, and now I'm seeing evidence of that. So I cannot in good conscience finish this knife out and sell it, as much as I would love to, because this was going to be this week's project and I need the money, but I can't do that. So I'll show you some pictures, and I'll show you some pictures of what I am seeing here that necessitates ending this project. Obviously the theory is sound, and keeping track of the temperature of the forge or the piece of work in your forge is, as always, important. And I just wasn't paying close enough attention. Used to the typical soak time for a billet like that I normally do, but the modifications to the forge raised that temperature, and I should have turned the PSI down if I was going to leave it in there for longer, and I didn't. So that is a bummer. Sometimes these things happen, but get this video posted up for you guys, and unfortunately there will be no knife to acquire from this particular build. I really like the profile on this. I might save this for a template, and I don't know, that's not really how I forge stuff, but yeah, don't know what else to say. So that's a bummer, but I guess that's the real world stuff that you get sometimes. So appreciate you watching, and we will see you on the next video.